You can't see or feel the force causing this globe to levitate, but it's not magic, it's magnetic. An essential part of our daily lives, magnets are used for a lot more than just sticking stuff to the fridge. They help run motors and generators, and are also found in computers, televisions, and microphones. Magnets occur in nature, but only 2 centuries ago, scientists figured out how to make them using metal and electricity. Production at the magnet foundry begins with the creation of a mold. A tray containing 4 magnet shapes is loaded into a machine that fills it with sand. A worker removes the pattern and smooths the surface dimpled by the machine's lid. Then it's back inside. This time, the machine pumps in gases that chemically alter the sand, hardening it in a matter of seconds. The sand slab is now a durable mold. And these molds are made in a wide variety of shapes and sizes. Now it's time to mix together the ingredients for the magnets themselves. They include copper, cobalt, sulfur, nickel, pure iron, aluminum, and titanium. All of these metals are loaded into an electrical induction furnace. It generates a pulsating electromagnetic field that heats the metal to almost 3,000 degrees Fahrenheit, melting everything into a molten soup. The metal is poured into the molds. Because the gases that harden the sand are highly flammable, the molds burst into flames. Still ablaze, they slide to another part of the foundry where workers knock them to the floor and bust them open with sledgehammers. This lets the air in, cooling the molds and allowing the gases to burn off. All of the pieces are shoveled into a bin, and workers separate the metal from the sand chunks using what else? A magnet. But these metal pieces aren't yet magnetized themselves. That will come later. A set of rings designed for use in electric motors is threaded onto a copper pipe. The ring-covered pipe is placed in a tube. Then, silica sand is packed in to hold the rings in position. Both ends of the tube are sealed with concrete. Then, it's into an electrical furnace. It heats the tube until it's red hot. This superheating primes the rings inside to accept an electromagnetic field, which will be delivered by this metal rod. The rod slides down the center of the copper pipe and is clamped into place. Water keeps the pipe from melting as a low-voltage, high-current charge is delivered to the rings inside. Workers break open the seal. The process has left the rings mildly magnetized. Any rough edges are smoothed away. At this point, the magnets are pretty useless. But this machine empowers them with a strong electromagnetic charge. The establishment of that weak magnetic field earlier ensures that the magnetization is now properly oriented. Now that's some serious magnetic muscle. The wide array of magnets manufactured today are critical to our daily lives because their invisible power helps keep so many things running. can't see or feel the force causing this globe to levitate, but it's not magic, it's magnetic. An essential part of our daily lives, magnets are used for a lot more than just sticking stuff to the fridge. They help run motors and generators, and are also found in computers, televisions, and microphones. Magnets occur in nature, but only 2 centuries ago, scientists figured out how to make them using metal and electricity.